Hello and welcome to the radio room. We're going to do the final adjustment on the HP204C, at least what we can do with the equipment I've got. Be running it off the junkbox power supply, and we'll see if we can't get it calibrated a little bit better, get a little more accurate on frequency, make sure that the waveform looks good, stuff like that. So let's get to it. And on the bench we got the HP204C, the junkbox power supply right here, and got the voltmeter up here. We're going to need to do some measurements. I already have the oscilloscope and frequency counter hooked up over here. Also got another lead here in case I need to measure some stuff off of that, using that alligator clip to kind of clip everything too. These binding posts aren't real easy to hook up to. Got a test lead hooked up to the ground on the back. It's going to give us a little bit easier access to our 0-point reference on this while we're doing some measurements. I went ahead and printed out. I don't think you all can see this. It's going to be pretty much washed out with the light. Let's see. Yeah, maybe that'll make life a little bit easier, at least temporarily. Well, first off, let me go over what we got here. Get this into a little bit of light here so maybe y'all can see it. Hopefully it's focusing okay. We're going to start right here about power supply. Before we make any adjustments, check the power supply voltages at test points 2 and 3. They should indicate positive 13 volts and negative 13 volts respectively. If the voltages have decreased to 11 volts to negative 11 volts, the Model 2OC may not meet distortion specifications. So what that tells me is that as long as we're higher than 11 volts and up to 13 volts, positive and negative, we should be able to operate this just fine. After that, we'll check the bias adjustments. Basically, that's going to be the balance between the positive and negative. That's going to the Wayne Bridge oscillator. They need to be balanced so that there's no difference between the positive voltage and the negative voltage. Otherwise, we would have like bigger peaks on the top side of 0 volts on our sine wave, and it might, be a different than the bottom. So it could probably not be balanced between that on the 0 volts if you're looking at it on an oscilloscope. We'll also check the automatic gain control. What that does in this system, in this circuit, is that it makes sure that the amplitude of the signal stays constant, so it's not going up and down. It'll take into account any, say, line voltage changes that come through the power supply and change voltage into the oscillator. If you are running this off of batteries, another thing it would do is make sure that as the batteries go down, the amplitude stays up and doesn't drop with that battery. Of course, once it goes below 11 volts, it wouldn't make any difference. And then we'll do AGC and frequency adjustments, and we'll make sure that the oscillator is actually putting out the frequency that it says it's putting out. So there'll be adjustments. All the adjustments, I'll show them here when I get the light back on here in just a moment. We'll go through and make frequency adjustments. It tells us in a couple of different ranges as far as setting the frequency, and then there's a high frequency adjustment that we'll do that will take it up to 1 megahertz. There's another adjustment for high frequency calibration. So let me get some light back on our test subject here. I don't have any power going on. We've hooked up I got the power supply hooked up into the back. One thing I do want to point out, I was kind of getting everything ready for this, and I actually looked inside of here. Hopefully I can do this without knocking everything off. I don't think you're going to be able to see it inside there. I was looking at where I had put the wires onto the back of that jack that comes into the back here, and one of them ran down to where we had our B+ connection before, where the capacitor was across the final capacitor was across the B+. There's this little piece right here goes all the way back to here. and there's kind of a shielded area at the bottom there where that slide connector was that's on the back panel. Well, the jack's above that. The wire needed to go to below that, and it was actually pinched up against the back side of this that goes all the way across here. That wasn't going to work because that's 13 volts rubbing right up against the ground. If the insulation had gone, it probably would have taken out the power supply and really jacked some stuff up. So I went ahead and took the back plate back off, found a new point to where run that wire to, and got that going. So there's nothing rubbing there. Everything's above this section now. So let me go ahead and get the voltmeter set up. I'm going to use right here as the 0-point reference. Oop, that just came unclipped. Let me get these things untied a little bit here. Alright, we'll hook this right up in here if it wants to stay. Huh. Well, we're going to make it stay. We'll just clip it in the clip, maybe. Oh, my tip is bent a little bit. Let's get that back in there. There, that should stay. Alright, we're going to check the B+. I think these labels are kind of washed out from the light, but the second one in here, test point in there, is our B+. So I'm going to go ahead and hook that on the B+, and hopefully it's going to want to stay as well. Go ahead and set this up to 20 volts. DC, and I'm going to go ahead and turn the power supply on. Looks like it already has voltage to that point. We're showing 12.46 volts. Remember, we had this set at 13. There's probably some voltage drop between where we tie in here, going through this cable. It's going through some circuitry to here. It's still above 11 volts. It's below 13. We're still in the range. So that's good. Actually, what I'm going to do is I'm going to take this off so I can just test. So now we're going to test the B-. And we got negative 12.7 volts. Once again, positive is 12.4. Negative is 12.7, so about 0.3 volts difference. Don't think it's going to make too much difference. We can probably adjust that out on the bias. Alright, so we've checked to make sure we're the plus 13, minus 13. The only other way to really adjust that is get inside the power supply and try to readjust it there. We're not going to do that right now. Let's do the bias adjustment. It says connect DC voltmeter to TP4, which is the bias connection, which is going to be this one on this side. Furthest one over there. This is going to have to stay in contact with it while I'm doing it, so I'm going to hook that on there. Let me find the right direction here that this thing wants to play, and we'll hook it on there. Let that set like that. Okay, I do not have the oscillator on yet, so we're going to find out if this thing's even going to work. We do have the power supply hooked up. We do have voltage there. That's a good sign. We have the positive voltage and the negative voltage where we need it. So everything's looking good so far. So adjust the R20 bias for 0 volt indication on the meter. Now previously in the manual, they had this thing basically just turned on. And we'll take a look at how it's doing right there. I'm going to reference one thing over here on the computer real quick while we're doing this, just to find out the conditions, if any, that we have as far as where they're at doing all their tests. It shouldn't make a difference which range we're in, as long as we're on. Which we're on. And just check, we're going to go through the ranges here. Yeah, see, the bias voltage isn't changing. So it doesn't really matter what frequency we're in. Frequency range we're in. Okay, so it says 0.43 volts. We need 0 on that. So we're going to do a bias adjustment right here. There's a little potentiometer in there. I'm going to do this very carefully. I have a metal screwdriver here. This is grounded right here. However, I am going down to a plastic connection down here, so we should be okay. So we're just going to adjust this bias. Whoop, and let's go the other way. See if we can't get that right at 0 volts. If we can't get this from 0 volts, we might actually have to go into the power supply and see if we can't make some adjustments on the supply voltage coming in. Okay, I'm just going to go just a little bit further. See if I can't get back to 0 there again. I think that pot might need a little cleaning. We're just going to zip back and forth a little bit here. And 0 volts on the bias. So we've got that set. Now we're going to go to AGC adjustment. It says set the Model 204C range switch to times 1000 and the dial to 1. So I'll do that. We'll go to times 1000. And then I'm going to set the dial on 1, which means it'll be putting out 1,000 hertz signal. So right there. And you know, just before we go too far here, I am going to change the camera scene here just a second and let you know that it's actually putting something out. So I'll inset the oscilloscope and the frequency counter. So there's our wave. So we do have a signal coming out. Get back up here, you can see it a little bit better. Nice looking wave. And we're a little shy of 1,000 hertz right there. That's 979, 980 hertz right there. Okay, so AGC adjustment. We've got our condition set on the front. We connect the DC voltmeter to TP1. So I'll go ahead and unhook from the bias. I'm going to go to TP1, which is the furthest one over here. Carefully hook to it. Now, it says adjust R24, which is this middle one right here, to negative 1.8 volts. So we're a little off right here. So let's see if we can adjust to negative 1.8 volts. If I remember correctly, when I was doing this the first time, this was a little touchy. This, from here on out, it got a little interesting. Oop, went too far. Like I said, it's pretty touchy. I'm just barely moving that thing. I'm just barely bumping it, trying to get on to right at 1.8. And I might be getting a little too crazy on this. Mind you, the last anytime anybody probably had to adjust this, they did not have a digital DMM. They were using an analog one with a really scale, so they were accuracy was a little more relative when this thing first came out. Okay, I'm going to stop right there. It might move around a little bit, but that's pretty close to negative 1.8 volts. So we'll move on. AGC and frequency adjustment. We're going to leave the DC voltmeter connected, just like we have it right here. And we'll connect the Model 204C output to the frequency counter, which we're already hooked up to a frequency counter. We're going to set the same range times 1K and the dial to 8, which should put us at 8 kilohertz. As you can see, we're coming up in frequency. The sine wave's getting tighter and tighter. We're getting a higher frequency here. So, just going to fine tune it down to right at 8 is where we're at now. And we're at 7.992 kilohertz. I'm going to make this so we can see a little bit prettier sine wave there. And you know, that really looks nice right there. We don't have flat topping. Let me see if I can spread this out a little bit more and we can see it better. That is a very nice looking sine wave. Let's see if I can sharpen that up for us a little bit. Very nice looking sine wave. Okay, so we're moving on. We're going to adjust C2 and C8, which is AGC and frequency calibration, these two right here, for 8 kilohertz and negative 8 volts. These are interacting, so this might change. You can already tell it's already changed. So as we play with one, the other one might change. So I'm going to start with frequency. See if I can't bump that up to right at 8. And once again, it's touchy. So 8 volts. Oh, might actually have to find me a different deal here. You'll notice that metal screwdriver is affecting my reading. So let me grab something that's not going to be conductive. It's going to make it a lot safer to do this anyhow. And we'll see if we can't get in there and do this. Get my swizzle sticks out here. See if I can find one that's appropriate. Probably this one right here I think will work. The only downside of these are being plastic, and these are just a little bit stiff. Sometimes these metal ones tear up swizzle sticks. So let's see if we can't adjust this without interference from a metal screwdriver. Besides, at least this way, if I accidentally bump the side, it's not going to do anything. Pretty fine tuning here on a stiff pot. Biggest problem I'm having is there's enough flex in this plastic tuning screwdriver that it doesn't, by the time I get enough torque on it, it almost kind of rebounds and goes past where I want to be. Alright, so 8 megahertz, or 8 kilohertz, pardon me. Now we're at negative 1.52 volts. So we need to make this other adjustment, try to get that to negative 1.8, which is probably going to change our frequency a little bit. But we'll get in here and adjust this AGC. And if you'll notice, it's raising our frequency as I'm raising the voltage here. So what I'm going to do is get it there. Okay. Now I'm going to adjust the frequency. Try to get it better. Okay, so I'm coming up on that voltage now, so I'm going to drop this back down. I know I'm not at the 8 kilohertz yet, but they're interacting, so I'm just going to kind of go back and forth. Try to keep this close to where it wants to be. You know, I'm going to leave that a little bit down. So now I need to raise the voltage just a little bit. It's probably going to raise that. Drop that voltage maybe. Get this voltage, this frequency back up to 8. Leave it right there. Get the voltage back where it's supposed to be. Adjust the frequency. This is a back and forth, back and forth. We'll get it in close. going to adjust the voltage. Adjust the frequency. Adjust the voltage. Just back and forth, back and forth. Okay, so what I'm trying to do here is I'm trying to watch both, find out kind of what the interaction is here. Does raising this up raise the frequency? It seems like it does. Seems like it does by quite a bit. So okay, now when I drop the frequency, what does it do to the voltage? Seems to raise it. Okay, so I'm going to go way beyond that. So I'm going to actually come down here. And I'm going to go below the 1.8. And then I'm going to raise the frequency. Oh, now it went the other way. This can be a little time consuming. We're getting close. I think we're getting close. Hopefully. Just do a little bit here and there, see what happens. Well, I thought we were getting closer. We're gonna get it though. Alright, 1.77 volts. We're at 8. Just gonna give it a little smidge here. A little bump here. Touch of a bump. Little bump. Back and forth real carefully. This can take a while, apparently. Do I dare? I'm calling that good. Negative 1.81. Oh, we're still moving around a little bit. Let me just do what nobody ever ought to do is just gotta get that. Oh my gosh. Did I go too far? right there. It's getting close. 8. Come on. Oh, she's touchy. She's so touchy. Well, I think I can live with just under 1 hertz difference. And our HEC is good. Okay. Now we're going to go back to 1 kilohertz and see if it's changed from 1.8 volts. Pretty darn close. Although it is a little off frequency right there. Okay, and then with the range switch set to the same range, adjust the dial for 10 kilohertz, plus or minus 10 hertz. Okay, 10 kilohertz. It's off a little bit. Okay, so it says recalculate the error between. Okay, we got it without moving the dial. Let's make sure we're on 10. We're on 10. Check the frequency ranges on times 5 through times 10,000 and record the error in percent. Okay, so let's go down to that. I think my frequency counter doesn't like reading 50 hertz. Oh, there it goes, 50 hertz. Just took a little bit to get there. Times 10. Should have 100. So that's like, let's see here. That should be reading 100. So that's, say, 3% negative. %3 negative. Go to times 100. That's 3% negative. Times 1K. That's just about 10% negative. times 10. So we should be at 100 kilohertz. So we are just about, that's under 2%. So we got a 13% difference between let's see, we want to take the average between the most positive and the most negative errors. So we had positive 10 and negative 3, so that's 7 divided by 2 is 3.5 positive. So we need to adjust this so that it is about 9,700. Now, let me see here. Which range am I in? Times 10K. I'm at 10. So that's 10 times 10, that's 100. Why are they trying to tell me I gotta... Frequency 10 kilohertz. That would be here. So I need to adjust that for... They're saying 97. 96.5, somewhere in there. I'm going to go with 97. Just reading through some stuff here, trying to make sure we're doing this right. Well, I'm going to reset this to where we were at. We're going to try that step again. Put this down at 8 again. Readjust these. I know this takes forever. I just kind of want to get this right. You don't want to play nice? Oh, we're going away the wrong direction. Leaving that right there. Okay, so let's read through this again. Try this again. We'll come down to negative to minus times 5. We'll let it settle there. Try something here. Okay, I want to check it 1 kilohertz. Sorry about that. Still 1.8, so we're good there. Alright, still just kind of reading here. Alright, so let's go to times 5. 50 hertz, by the way, so that's lower than line voltage regular, frequency. She doesn't want to play. Frequency counter's a little. Oh no, I'm not. Actually, I need to go to. Need to go to 1K. Get myself confused here and go to 10. I'm missing a step here. And our AGC is pretty good. Alright, now we check going down to times 5. So it should be 50. That's pretty much right on. Going to times 10 should be 100. So that's negative 3%. Times 100, so we should have 1,000. Just under negative 3%. $10K. Just under 1%. Correction, that'd be about 6%. And 10K. Now, hold on a second. Let me go back here for a second. Yeah, it'd be about negative 6% right there. And that's negative, just over 1%. So our worst one's negative 6%. We got negative, what was it, 2% back here. Negative, that should be 100. Less than 3. Negative 6. Less than 2. So like negative 8 divided by 2 is negative 4%. Well, I just don't know if I want to put that down that far on that. Such a beautiful sine wave. It's actually closer on all frequencies to saying what it should be than if I do the adjustment. I don't know why they want me to do that adjustment like that. So we're going to skip that. I mean, this thing, I mean, look at this. That's another 4 hertz, 2 hertz, 2 or 3 hertz, and it's right on where it's supposed to be. Go to this range. 30 hertz, and it's right where it's supposed to be. Less than 30 hertz. That one's off 60 hertz. Now, mind you, that one's off by about 1,000 hertz. But I really don't see how that's going to make our adjustment make it any better if I bring this down to that. So you know what? We're just gonna keep that where it is. I think this is going to be more accurate if we leave it where it's at. Oh, well, that might be true too. That would actually bring it up. Because if it's a negative, then it would bring it up. So, I don't know what the hell. Let's play. So if I decided 3 hertz, so I'd need an adjustment on that going the other way. I really hate to do this. I think I'm just going to play with the frequency just a touch. This is probably the most boring video ever, huh? Alright, I like that. Pardon me for a moment. I need a little bit of drink of tea. Alright, now we're going to move to the next step, which is going to be the last step we're going to be able to do because I don't have a distortion meter. Okay, we're going to set it to the 100K. It's the highest range it has. And connect to the frequency counter, we're going to adjust C4, which is the high frequency calibration, to indicate 1 megahertz plus or minus 1 kilohertz on the frequency counter. So we're going for 1 megahertz. Yeah, let's get that nice little sine wave going there. Alright. Now, we just need to adjust our high frequency calibration so that it's, and I'm going to actually go to 1 megahertz here. And get this down to plus or minus 1 kilohertz. Close. Oh. Looks like it's going to move around just a little bit. Just touchy. Let's see if this one even makes a difference on the... Ooh, it does. How about this? Yep, can't use metal on these ones. Well, you almost just even think about moving it, and it changes a lot. I think we're going to stay right there. That is definitely with 1 megahertz plus or minus within one kilohertz. That's, well, 240. So that's definitely going to take care of that, and that's really the most calibration we can do on this with the equipment that I have. So I'm hoping everybody enjoyed this. Let's play with it just a second here. So let's try 500 kilohertz. It's not bad. It's, feel a little off as far as the dial. Let's want to do an experiment here. Let's get down here to, it should be 100. That's a little off. There we go. Five hertz. I'm sure we can. That's a half second on per division. Hertz. Hundred hertz. $1,000 hertz. $10,000 hertz. $100,000 hertz. So I'd say it's going to work pretty good. It's not dead on, but we're talking, early 1970s technology that's been bouncing around for a while. I'm going to recheck our voltages here. Let me see if I can get this out of here real quick. This thing's been running for a while. Yeah, it's come down a little bit. That's full amplitude. You can see the amplitude changing there. So that's all the way down. Let's see, that's at 20 millivolts per division. So that's probably 15 millivolts, looks like. It's maybe a little bit more than that. 17. So it turns down. One thing I did want to do is let me come up here so we can. So according to the manual, this thing should do unloaded with no load on it. So I'm going to unhook the frequency counter. And that. So that's unloaded. This thing should have at least 5 volts peak on it. Let's go to AC. It looks down a little bit. Oh, that is in the ×5 scale, by the way, that you're supposed to check that. And yes, it does have at least 5 volts on it. You'll notice it's jumping around a lot, and that has to do with where it's seeing the wave. This is very low frequency here. Let me see if I can increase it and get a little better reading. It's coinciding with where the peak of the wave is, because this samples. It's not constant. Let's see, now you can get a little bit better read here. Of course, you know, that's at a lot lower frequency. You can see as I come down in frequency, it actually goes up. But it's more a sampling problem right there. If this was an analog meter, you wouldn't see that. Go ahead and hook this back up. Get some frequency on there so we can have a pretty show. As you can see, goes all the way down. So, you know, on that particular range, I mean, I can go real low there. Oh, so it's almost hard for it to trigger at that low of a. It's just so low. It's barely triggering. So there you go. It works. Seems to work really good. Our voltage is maybe just a touch low. 12.3 on our B plus, 12.6 negative on our B minus. Still within specification. Don't really have any heat coming off the back of this, so it doesn't seem like those ICs are getting very hot. Which is a good thing. It's been running for a while. I mean, this thing's running full bore here. Crank it up here where it's really working its highest frequencies, maximum amplitude. Yeah, it's gonna be good. Let's get this thing max frequency here. She don't go no higher than that, guys. That's as high as frequency as it goes. Let's see. Let's put that over there. So 1.25. Let's see. Is that absolutely everything we got? That's everything we got. 1.257 megahertz. So 1257 kilohertz. 5 to 1.2 megahertz. That's pretty good. I think it's going to work good. Well, I hope everybody enjoyed this video and enjoyed this series. I know this one was kind of long and had a lot of dead time in it, trying to go with getting these two taken care of. But I think it's going to be good. We'll go ahead and end the video here. If everybody gives me a good big thumbs up. Oh, gotta get my thumb over there where you can see it. Hi. And see if we can't explore some other things in some future videos. I'm glad everybody kind of rode along with this. Started out with just plugging this in, seeing if it even worked, and became a project in and of itself. It's taken a little bit of time, a few months. Doesn't have really to do with the fact that it took that many months to do the work. It's just that it took some time to have the time to actually get in here and work on this. So I'm going to go ahead and shut this down and shut the video down, and I hope everybody enjoyed this. And like I said, we'll have some further things coming up, hopefully in some future videos, and hopefully not too long from now. We'll just have to see what kind of time we have. I still have to pay the bills, so once again, thank you for enjoying the ride with me, and we'll go ahead and bid you adieu. Go ahead and give me a thumbs up and subscribe, please, and we'll see you next time.